The same picture. Do you think what it is? Design. It's a computer. So who knows? This will be the question of your final exam. Really, one time I used that figure for one of the questions in the advanced database course. At the time, that advanced database course is different from this, but anyways, this is a server. So we have another the box representing what?
OS.
So operating system. Any computer device needs such a software, especially the computer needs the operating system to utilize the resource of the computer. Without the operating system, actually we cannot use that very fast computational power or the huge storage. We cannot use that computer resource. Thanks to that power of the operating system, we can utilize the computer resource. Then we have another one that is the application program level. In this class, this represents
The
DBMS. As you can see, this is the computer architecture, right? Core course. This is operating system. It's a core course. This is the DBMS database. It's a core course. All these are the core course in computer science subject. The most important part. Okay, to implement the operating system and DBMS, you should know the programming. So that's the reason you are taking one of the program language course in computer science, the major, right? Right now it's object-oriented programming. Is it part of the core course? Yes. What's the another one? It's AI. Artificial intelligence, algorithm. This is an algorithm, right? Algorithm is also the part of the core course. So those are the main subject in computer science. So we'd like to access from the client. So this is a server. Most of them are computer. It's usually, not always, server is the high performance power computer rather than the client. Not always. So sometimes the server can be client. So when we divide into the server and client is who provide the service. So in this case, we are focusing on the database service. So the server that includes the DBMS is the server. On the other hand, the client where you can access the DBMS. So using the client module, for example, your project B output can be the client module of the DBMS, right? So using the SQL application, you can access the DBMS. There are several issues when you access the DBMS from client. So there probably network will be involved. I'm not going to explain detail. I did one time before. So network also should be considered in the database system also. Then, anyway, we can log on the DBMS. So we'd like to send the SQL, like the select ID from employee name, where ID equal 111. So the process, how this SQL is processed in the server related to what? Query processing and query optimizer. We already discussed in the last week and last 2 or 3 classes. We know, right now we know how this SQL will be processed. And so today we'd like to see what's going on after this SQL is processed. What's going on? How we know how to access the data. Then we'd like to know how DBMS handle such a request. So this will be submitted to the DBMS. Then it will be parsed, so there might be P code, parsed code. So this parsed code has how to access the data, like the execution plan. Before DBMS find the location of the data, employee name, ID is 111. First, they try to check memory area, right? Whether there exists cached data. Okay? So that area actually is reserved when you start up DBMS. For example, Oracle, this area is called SGA, System Global Area. This memory area is reserved for DBMS only. Purpose is a cache purpose to speed up. So first take a look at whether there exists the name whose ID is 11119. At that time, the basic unit is what? It's a block. It's a DB block. Okay, we know what is the operating system. OS block usually is a 512 byte size. It's a basic unit of input and output. Similarly, database has the DB block. It's the multiplication of the operating system block, which means 1K, 2K, 4K, 8K, 16, 32, 64K. Okay? The largest one ever I seen was the 64K block size, DBMS. Anyway, so this is the block. For example, 2K size block that includes this one. So you can take a look at all the block, whether there exists the block, including the name ID is 111. If not, you will find the block. So this is an employee table that includes the name is LEE. Then, if you can, how can you find that block? Using execution plan, okay? That we discussed last week. So, for example, the employee using the ID, primary key, you can access the data. At the time, you can use the primary key search, then get the data. So, this is the way to find the data. But before you return the data to the user, this block LEE will be copied into the memory, okay, for reuse later. Okay, then Lee will be returned. Next time, I submit the same query. Okay, at the time, it will access the data to the hard disk drive. Database, no. At that time, this memory will be returned. Then we can reduce the access time drastically. That's the way of the speeding up to to search the data using DBMS. Okay. Then the problem is we have another user who'd write update employee, set name equal JK, where ID equal 111. If we have only the read, or if we have only single user, there might be no problem. You can access the data either from memory or hard disk drive. What if we have another user? This is a user A, this is a user B. User B log on the DBMS, then submit the update. The same data. You think what happened? First, you need to search the data. Okay? Right? In case there exists the data in the memory, you can update the data. Right? You can update the data. So, before you update the data, so let's say, so this is the Lee. Then, update the data, JK. Okay. Any problem? What about this one? It's a Lee or JK? It's a still Lee. Then what happened?
It's different.
And another problem is, right after updating, so user A submit the same query. Select name from employee where ID is 11. Then access the data. Is it JK or Lee? Should be? I don't know. So it's very complicated when you consider multiple user system. Single user system doesn't matter. It's a serially you can process the data. Select, then update, yes, update, then select, it will be JK, there's no problem. However, when you consider multiple user, it will be much, much more complicated. How can we address such a problem? Any idea?
Lock.
Then go back to the operating system class. I think who is taking operating system class? There might be. I think right now you are discussing about this kind of problem in operating system class. It's the same problem actually. The only difference is that we are using different data structure. We are using different data model, relational database model. Operating system use the same thing. Operating system has the same problem. For example, what is the racing in operating system? Racing. Race. Car race.
Competition.
Sometimes two user compete, two process compete with the same data, shared data, right? So, for example, there's a data I equal 1. Process A has I plus. Process B, I minus. If you run process A and B same time, what will be the output? Is it 0? Is it 1? Is it minus 1? Or 2? That's a problem of the race condition, right? When two processes compete with the one shared data, you need to consider something. At that time, what is the solution? There are several solutions, but we define transaction. So, have you ever heard about transaction? Yes. Transaction, everybody knows what transaction is. So what is a transaction?
It's an operation.
It's operation. But a little bit different from operation. Operation is kind of I plus or minus sign. This is operation. Or add, substitute, multiply. That is the operation. Operation is atomic unit in assembly, right? Then, because even though we have operation, there might be the problem of this one. How can we solve that problem? We will define transaction. Transaction is what? A set of operation. It's a logical unit. It's not the physical. Physical unit is the operation. But when we consider only the physical unit of processing, it may cause the problem. So we are defining the transaction. It's a logical unit. It's a set of operation. That is the atomic transaction, atomic unit, which means it will be done at the same time, logically. So it's the same idea. Here, in database, we need to consider such a similar concept, that is the DB, database transaction. The database transaction is a set of database operation. What is the basic operation in database? Read the data, search, select the data, read, and write. Writing means update, delete, insert. So all of them are considered as writing. So read and write, two basic operations. Combination, a set of read and write operation is considered as the database transaction. So by considering the database transaction, we can solve such a problem. So in database, we define the database transaction as begin and end transaction. All database transaction begins with begin transaction, then end with end transaction. Then this set in between begin and end, there might be a bunch of different database operations such as select, blah blah blah, and insert, delete, update. But until you meet end transaction, it's not complete yet. Okay? When you see end transaction, all of the changes, if you have only the read only, then no problem actually. You can share, you can read many transactions, many users read the same data, and no problem. But when you have the write, it may cause a problem. So until your transaction meet end transaction, all change will not be applied. Okay? In other words, when you meet the end transaction, it will be ended of the transaction. Then it will be applied. For example, in this case, so I'm going to start begin transaction. Then submit this one. So first it was Lee, L-E-E. Then update JK. It's not done yet. Before end transaction, if user A try to read the data, it should be Lee or JK. Which one? It should be before data, Lee. Okay? But we do not have such a Lee data here. So to address that problem, when you update, write the data, first is a Lee. Copy this one. So this is before, this is after, new one. Then modify this, update this. This is a before image, this is the after image. So right now we are before end transaction. If this transaction try to read again, select the same data, it will return JK because it's in the same transaction. Okay? However, if the other user try to read the data before end transaction, it will be before image. So when you update the data, when you write the data in database, first you need to copy. Then update after transaction. This is called sometimes dirty image, or sometimes dirty buffer, dirty block. And this is a before image, before data, before block. So you need to copy in memory. Okay? Then end transaction. End transaction means we don't need before data. Right? Then it will be applied. At this time, if another user read the same data, it will return new data, JK. What if this one? Sometimes the hard disk drive, permanent, the secondary storage should be updated. Do you think when should it be updated? Same time as buffer. Number one, same time as buffer. 2, after sometimes later. This one. 3, don't care. Which one?
Number 2.
If possible, we try to update at the same time, right? That's perfect. That's the idea. However, if you try to update at the same time, what will be the problem? I/O. That means delay. How fast? Millions times of faster than hard disk drive, right? So this transaction should wait until hard disk drive is updated, right? So it's a long time. All transactions should wait to be completed. So we are not going to update the hard disk drive directly. Only memory is updated. It's called the delayed writing. Delayed writing. So hard disk drive is not the same time updated. Where can you see such a similar example of delayed writing? Where? What if I unplug the USB? Is it okay?
No.
It's not okay. Why? You need to confirm. Okay? Safe remove. What does that mean, safe remove? Some of the writing is only in the memory because of the same problem. So before I unplug this one, you need to write all the changed data into the hard disk drive. Okay? Otherwise, you will lose some data. It's very, very serious. It's okay if I unplug his data because he only lose some
Connections.
the email for his girlfriend. Right? But however, if you lose the data from here, it can be some banking account balance, right? I transfer the money, so it's not updated. Yes, it's okay because I got the previous image, whatever. So it will be serious. So you need to flush it from time to time. Okay? So this is a delayed writing. Okay? So this is one common mistake. The database will be updated whenever I update the data. No. Database will be updated only in the memory first time. Then from time to time it will be applied to the hard disk drive. So before hard disk drive, secondary storage updated, if somebody would like to access the data, it will be served from memory. That's it. So no problem. How can we implement such a thing? Using transaction concept. Okay? Because of the transaction, so we can address such a problem. So transaction is the very, very important concept and very, very actually expensive module. For example, SQL Server, which is one of the popular in the middle, small size system. Actually, SQL Server didn't support such a multiple user. It was just a single user system, just like the Microsoft Windows a long time ago, 95. Have you ever used the Windows 3.1? 95? So at that time, it was a single user system. There is no sharing concept, no the multiple transaction. Because of that, SQL Server was the single user system. But after the Windows NT and the Windows Vista, right now the Windows 8 is a multiple user. It can be server, then have the many connected client module and the remote login and multiple user. So they need to, Microsoft SQL Server need to support such a transaction control module. So they actually suggest the transaction module from the Sybase. Have you ever heard about Sybase DBMS? It's another DBMS system, relational database management system, which is very, very good for data warehousing system. It supports something the very fast column-based access, something like that. So anyway, that is a transaction control. So today we are going to learn about such a. I already explained the most of the concept of the transaction concept and theory. How DBMS utilize such a thing. Also, transaction will be used for concurrency control. Concurrency control means there are how many users do you expect in your database system? Sometimes 2, 3, but sometimes millions of database users. We would like to access the same database. Some of them just read the data, but many of them update the data. Sometimes many users would like to access the same data or read the data. As you have seen, this is just one example of the concurrency problem. Concurrency problem in database. Concurrently, how we can support concurrently access the same data. Concurrent user, many users access the same data. So transaction can be used for such a concurrency control also. Another way of using transaction is recovery. What is a recovery? Why do we need a recovery? Somebody will say, if we never fail the system, we don't have to worry about the recovery. But actually, unfortunately, there is no fail-free system in worldwide. Any system like this one, and your smartphone, the firmware, small device has the failure every time, everywhere. Sometimes operating system allow such a failure. What can be the example of such a failure? For example, deadlock situation. So did you learn the deadlock in operating system? What is a deadlock? Stuck in the system. For example, process A has the item 1. Process B has item 2. Then try to access this one, and process A try to access this one. Wait each other. Same time. Okay? This is kind of deadlock situation. This is kind of failure. Because system is not running, it's a stop. What can be the solution? Actually, operating system ignore such a thing. Really, why don't you look up the operating system textbook? This is one of the popular solutions, ignore. Then user will interrupt. Or Control C, for example. If your application is not running, so not responding, most popular word in Windows, not responding, what is the solution? Kill the process. Or Control C, right? This Control C is the kind of interrupt signal, okay, to interrupt the stop. So each process is in charge of such a thing. Similarly, database has a lot of failures. Like if I throw away his computer, then it can be the system failure, right? At the time you want to restore, recover such a problem. Even when I unplug his USB drive, even that can be the failure. There are a bunch of different failures. Then database also has such a failure, but if operating system is fine, sometimes ignore. Even though there exists a failure, operating system can ignore such a thing. Then we do it. Sometimes you close falsely the specific application, then restart, no problem. Sometimes you can recover, but it's not entirely recovered. But you can use the previous version. But database is not. It should be failure-free or 100% recovered. So at that time, transaction concept can be used for recovering the system. I will give the one example based on saying this one. So I try to update the data. So Lee to JK. So this is before image, this is after image. But right now, hard disk drive as the Lee. Okay? Then I try to end. End transaction. There are two operations of the end transaction in database. One is commit. Commit means apply any change so far permanently. Okay? For example, copy, then erase the before image. Alright? That is a commit. So that's the reason sometimes. So some of the students already complain, ask to me. I update the data. Then when I select the data, yes, the new data can be retrieved. But if I log on using another SQL Plus, I cannot see update the data. That is because of you do not commit the data. Some of the students say, I never commit the data, but it's already applied. Because when you close the session of SQL, when you close this connection, you can set up the default option, automatic commit, or not. Sometimes not, sometimes yes. Also, in your application program, database programming, so apply automatic commit when you close the transaction. Okay? That doesn't mean there is no commit. Commit will be applied sometimes automatically. Sometimes explicitly you should commit. There is another end of transaction that is rollback. Rollback means we do not apply the dirty buffer, go back to original. In this case, erase all the after image. Then go back to the original, rollback. That is the end of a transaction. But this time, we are in before, neither commit, neither rollback. So which means, so right now, Lee will be served. Then I commit the data. Which means it's a permanently applied. So right now is JK. What about the hard disk drive? But hard disk drive will be updated lately, delayed writing. Okay? So this is still Lee. When a user A access the data, it will be it's a Lee or JK. It's a JK because I already commit. It's the end of a transaction. Okay? This time, somebody unplug the power of this server. Okay? Which means all process will be killed first. Because what is a process? Process means it's in the memory. Right? Program module in the memory. What is a memory? Memory without power is a volatile. Right? So you will lose all the data in memory without power. Right? Then it will be. Then I found. So somebody unplugged. So I plug in again in the power, then start up again. Then when you access the same data, select the name from employee where ID is 111. Is it JK or Lee? Before or after? Which one?
It should be JK.
It should be after, right?
Yeah.
Because we already commit. Commit means permanently applied. However, you already lost all the data in the memory. We do not have JK. So you need to access hard disk drive, storage. It's still Lee. What happened? So it's inconsistent. It's called a database consistency. So in this case, it's an inconsistency. We need to address such a problem. So this is one of the examples of the failure and one of the examples of the recovery. So actually, before you commit to address such a problem, it should be JK, but we do not have the JK. So before you commit the data, actually all the action of the change, like the Lee to JK, any change should be written in the log data. This is called write ahead log. In the write ahead log, your action, which means not the whole the change data, this update Lee to JK. This statement should be logged, journaled, okay, before you commit the data. So even though this one is a failure, because of this is called instance failure. Even though you lose the data in the memory, when you start up the DBMS system will check this log information. Log information is based on such a transaction. So check the transaction. This transaction actually has the timestamp. Check this one. So update Lee to JK should be applied at time 1, for example, time 1. But when you go access the real data in the hard disk drive, it's still Lee. It's a time 0. It's a old data. So you can apply this one when you start up. That is called redo operation. Do it again, redo. Actually, we apply the read to JK, but it's not applied to the hard disk drive. You need to redo. That redo operation will be based on such a transaction concept. Another one is undo. Undo operation means, for example, I update. It's quite similar thing. It's based on the same transaction concept. I update the old employee. Update employee. Set salary is 10 times increase. 10% increase apply. I have 10 billions of employees, which means 10 millions of employees. Before image, after image. Before image, after image. Before, after should be copied in the memory, right? However, how big is your system global area? It's limited. Sometimes 1 gig, sometimes 2 gig, sometimes several gig. But it's not only for this one, it can be used for many of the area will be used for the cache area. So even though it's before and the transaction commit, some of the before image and after image should be copied to the hard disk drive. This one is also hard disk drive, secondary storage. This is called rollback segment. Or sometimes hard disk drive will be updated even before commit. Okay? Because of the limited size of memory. Then, if the system is failed before transaction, this one is, for example, JK, but should go back, undo, go back to the original data. Okay? It's a consistency problem. So at that time, you can use transaction concept. So transaction concept can be used for concurrency control, even consistency control, and backup and recovery. So it can be used variety of the database management issue. Okay, that is also different concept of from the file base. I know some of the operating systems utilize a similar concept, but not intensely. Database, such a database consistency is very, very important in database. Okay, so we will talk about such a transaction. I think that today we can complete the transaction processing and concept and theory chapter 20, and Thursday we will do one more chapter that is a concurrency control. Okay? So these redo and undo operation are two basic operations in database backup and recovery. Some of the people are struggling to understand the concept of the backup and recovery. Somebody said backup and recovery is very, very important. Yes, that's true. When I joined the company first time, it's 1995, so already almost 20 years ago. First time, my supervisor actually said to me two questions. Ask me just one question. So he asked me, do you think what is the most important task of the database administrator? So I didn't know anything about the database. Even I didn't major the computer science. I didn't know anything. He said the first important thing was backup and recovery. Okay. So if you have a very nice programming skill, yes, that's better. However, if you fail the backup the data, like for example the hacking or some disaster, natural disaster, or even the terrorist attack like the 9/11, at that time, if you, it's sad if we lose the casualty or the people, but if you lose the data, it's almost impossible to recover the data. At that time, one of the best way to restore such a data is backup. So you need to back up the data, even your personal information, personal data. So have you ever back up your data? No. He's not serious. Even for me, I usually doing backup once a year. So I believe not many professor, not many students backup periodically. But without backup, you cannot restore in case the data, right? It's very important. So that's one thing. Another important task of the database administrator, you guess what that is? Any idea what is the second important thing?
The security.
Security? Yeah, right now security is very important. But I don't think security is more important than this one. Any idea? Speed? That's the first one.
Backup location.
Backup location is part of backup. So that's also important. When sometimes after you believe you back up the data in the same local hard disk drive. That does make sense. Also, even sometimes you need to back up the external storage, then move to different location. For example, one of the company, I think the Bank of America has 7 different locations for the backup. So which means even one of the location got the earthquake, still they can. But that's the part of the backup and recovery. Is that the second important task of the database administrator is documentation. Documentation is the most important, which means whatever you did or whatever the things happen, you need to keep documenting, keep journaling. That will be. So for example, something wrong, I think. But, okay. For example, for me, I left my old company after 5 years later. Then there might be some others who take over my job. But if I didn't have any documentation, the new person is very, very hard to continue the system management, right? Also, even though I implement something new ideas, new technique, but if I do not keep record of the history, it will be very hard to share with the others. So documentation is a very, very important task for any types of administration. Okay, so that's the second thing. But in this class, we are going to focus on such a transaction, backup and recovery, and used for the backup and recovery transaction control. Okay. So if we have the single user system, let me try. I don't know what happened. Interesting. This is better. Okay, if we have the single user system, we don't have to worry about such a transaction control. However, most of the system right now, the multiple system, so we need to consider such a transaction control. So concurrency is when you have, concurrency control means when you have the multiple user, multiple system, then you need to guarantee your system. Okay, for multiple user. There are several ways of the concurrency control. One is the interleaved processing. What is the interleaved approach? Have you ever heard about the interleaved approach? Yes, you should. In operating system class. So I have taught operating system class same time as the database long time ago. What is the interleaved? For example, CPU time. How many CPU do you have? Usually one. Then, how many process do you have? Many process. How can you share it? It's the interleaved approach. First, you can process A, process B. This time, process A. Usually, process A, any process has a wait for disk I/O, right? It has been a long time. At that time, if you wait just until you got the response from the disk controller, it's useless. So why don't we use this time for another process? That is interleaved processing. In database, it's the same idea. We can share the one time from now and 10 seconds is a process A. See, A user, then B user, A user, B user, something like that. Parallel processing concurrently you can run when you have the multiple CPU. So we are going to consider transaction to support such a concurrency control. So what is the transaction? Transaction is the logical unit of set of database operation. Basically, read and write. Okay, write include the update, delete, insert. So transaction is in between. Start with the begin and end with end transaction. By the way, have you ever typed begin transaction? Have you ever learned begin transaction was similar thing? Actually not. What Professor Lee said, transaction should begin with the begin transaction and the transaction we mentioned, commit or rollback. Sometimes it's automatically committed or automatically rollback. What about the begin transaction? Is there anyone who used? Sometimes yes, you should use, but most case it's automatically start with the application program, which means when you double click SQL plus, transaction will be begin automatically. That's the reason you do not realize the begin transaction. Okay? So there are two main operations, read and write. But there are granularity in database also. In operating system, it's the same. Granularity means like the lead. It's a data item, just item, smallest item. Even it's not record, it's a column data, one column data. What is? Entire record. So all the information